Chalo, let's start. We'll start with a new chapter which is known as matrices. First of all, we need to understand what is a matrix. हम मैट्रिक्स किसको बोलते हैं? अगर उसको समझ गए, टाइप्स ऑफ मैट्रिक्स अगर समझ गए, then we'll start with next topics, sum and difference of matrix. Matrix, the arrangement of numbers elements in any order is known as a matrix. मतलब अगर हम numbers को और elements को कोई order में arrange करें, here this word order is very important here. अगर हम कोई matrix को कोई order में arrange करें, if we are arranging any numbers, अगर अपन numbers को arrange कर रहे हैं या अगर अपन elements को arrange कर रहे हैं कोई एक order में, उसको आप matrix बोलते हैं. Order, what do you mean by order? Order in a sense number of rows. अब इसमें कितने rows है? This is known as row 1, this is known as row 1, and this is known as row 2, this is known as row 3, this is known as row 3. We are having 3 rows in this matrix, as well as we are also having columns, right? This is column 1, column 1 for of a matrix. This is column 2 of a matrix. This is known as column 2, this is known as column 2, and this is known as column 3. ये 3 rows and 3 columns है matrix की, column 3. So M is known as R, row, and N is known as column. We are having 3 rows and we are having 3 columns in this matrix. So this 3 by 3 is defined as order of a matrix. If we are arranging numbers elements in any order, मतलब कौन से भी order में, order can be 2 by 2 also, order can be 4 by 4 also, order can be 3 by 2 also, order varies. ठीक है ना? order vary हो सकता, order change हो सकता. तो we'll discuss what is order. ठीक है ना? अगर अपन order समझ गए then we'll understand what is matrix. okay? हाँ, let's start. Let's understand what is order. Order of a matrix is defined as number of rows to its number of columns. मतलब number of rows by number of column is known as order. How many number of rows we are having in a matrix and how many number of columns we are having in a matrix is known as order. Let us see some example. Example problem number 1. See, in this matrix we are having, this is known as row, we are having, this is first row and this is second row, this is first column and this is second column. So order of this matrix is 2. We are having 2 rows and we are having 2 columns. So order of this matrix is 2 by 2. And let us consider this second matrix. We are having 3 rows, row 1, row 2, row 3, column 1, column 2. We are having 3 rows, we are having 3 rows and 2 columns. We are having 3 rows and 2 columns, 3 rows and 2 columns. So order of this matrix is 3 by 2, order of this matrix is 3 by 2, order of this matrix is 2 by 2. Let us consider third example. We are having first row, this is the first row, this is the second row and this is the third row. So we are having 3 rows and we are having 1, 2, 3, 4. We are having 4 columns. So order of this matrix is 3 by 4. What is the order of this matrix? We are having 1 row, this is second row, this is third row, this is 4 row, fourth row. 4 rows by how many columns we are having? Only we are having a single column which is 1. So 4 by 1 is order of this matrix. So order of a matrix is defined as the number of rows we are having by number of columns in a matrix is known as order. Now let us understand what all different types of elements are there in a matrix. So this A, this A and this A, all the A's which are in this matrix are known as elements. We say this as elements. These are known as elements of a matrix. Okay, and this 1 1, this 1 2 and this 1 3, this 2 1, this 2 2, this 2 3 are position of a matrix. It which means in which position these elements are there, we define that as position of matrix. ठीक है ना? Like 1 1 in a sense the A element is in first row and first column. 1 2 in a sense the second element A is in first row and second column. You can see it is in first row and it is in second column. So this A are known as elements. This 1 1 1 2 1 3 are known as positions of a matrix. Now this A11, A22 and A33, this A11, A22 and A33, this is known as principal diagonal element. This is known as principal diagonal element. Principal diagonal element. In this matrix there are two diagonals, this A13, A22 and A31. This is also one diagonal, but this is not principal diagonal element, where the position of rows and columns are same. As you can see here 1 and 1, here 2 and 2, here 3 and 3. If the position of this row and this column is same, is known as a principal diagonal element. Okay, and the elements which are above principal diagonal element, you can see that these three elements are above principal diagonal elements, which is A21 and which is A13 and which is A23. These three elements above principal diagonal element is known as upper triangular element, which is known as upper triangle element. And the elements below principal diagonal elements, how many elements are there? These three elements are there, which is A21, which is A31 as well as A32. These three elements below the principal diagonal element is known as lower triangular element. Lower triangular element. We have seen what is principal diagonal element. The diagonal elements in a matrix is known as principal diagonal element, but which should have its same position. Means it should be on its same row and same column. It should be on its same row, same column. It should be on its same row, same column. This is known as principal diagonal element. And the elements which are above principal diagonal element is known as upper triangular elements, which means there are three elements, A21, A13, A22. These three elements are known as upper triangular elements. And the elements which are below principal diagonal elements, A21, so A21, A31 and A32, these three elements are known as lower triangular elements. This was a short and brief introduction about matrix. Now let us see different types of matrix. Here first matrix is a square matrix. How we define a square matrix? If the number of rows and number of columns are same, if R is equal to C, then we say that the given matrix is known as square matrix. Like here it is given 2 by 2 matrix, this is a square matrix. Like if the order of the matrix is 3 by 3, then this is also a square matrix. If order is 4 by 4, that is also a square matrix. So simple definition for a square matrix is, if the number of rows and number of columns are equal, is known as a square matrix. Similarly, rectangular matrix. How we can define a rectangular matrix? If the number of rows and number of columns are not equal, like the number of rows are 3 and number of columns are 4, number of rows and number of columns are differing, so this is known as a rectangular matrix. How we can define a row matrix? Only single row must be there, we should have only a single row, and we can have a many number of columns like 1 6 minus 9 3. This is also known as a row matrix. Here we are having only one row, and how many columns are there? This is first column, second column, third column, fourth column. We are having 4 columns over here, and we are having single row, so this is known as a row matrix. Then next, column matrix. In column matrix we must have a single column and any number of rows can be there. Like for example 1 6 9, 1 6 9, this is a column matrix in which we are having only a single column and we are having 3 rows. Okay. uh, then next, fifth one is zero matrix. All the elements in a matrix must be zero, is known as a zero matrix. And next, identity matrix. Principal diagonal element should be 1, we should have a matrix in which principal diagonal elements must be 1, like 1 0 0 0 1 0 0 0 1. We should have the diagonal of principal, like this is 1 0 0 0 1 0 0 0 1. What is principal diagonal element? Just now I have discussed. We should have same rows and same columns. This is known as a principal diagonal element. So here we should have only one, and upper triangle element and lower triangle element should be 0, is known as identity matrix. Identity matrix can be of 4 by 4 also. It can be of 2 by 2, as here this is identity matrix of order 2 by 2. Okay, this is identity matrix of order 2 by 2, where the principal diagonal elements are 0, sorry, principal diagonal elements are 1, and upper triangle and lower triangle element is 0. Identity matrix is also known as unit matrix. We call identity matrix also as unit matrix. Okay, scalar matrix. What is scalar matrix? The principal diagonal element should be same, but that should not be 1. The principal diagonal element should be same, and the upper triangle element and lower triangle element must be 0. For example, 2 0 0 0 2 0 0 0 2. This is a scalar matrix. The principal diagonal element is 2, and the upper triangle element and the lower triangle element is 0. This is known as a scalar matrix. Okay, diagonal matrix. What is diagonal matrix? The diagonal elements must not be same and must not be 1, means you should not have 1 in diagonal element, and you should not have same numbers like 1 0 0 0 2 0 0 0 4. This is also, this is a diagonal matrix where upper triangle element and lower triangle element are 0, and the principal diagonal elements are having only some values, is known as a diagonal matrix. What is triangular matrix? Triangular matrix is known as, like, see, this is, let me explain you what is triangular matrix in detail. See, triangular matrix means this is an upper triangle, and upper triangle elements are 0, so this is known as a lower triangular matrix. If upper triangle elements are 0 and rest all elements must have some value, so this is known as lower triangular matrix. If the lower triangular matrix elements are 0, this is known as upper triangle. If lower triangle elements are 0, this is known as upper triangular matrix, and rest all elements must have some values. This was lower triangular matrix and upper. This was all about matrix. What this was all about, what is matrix, and we have discussed different types of matrix. Now let us do in this section, in this session I'll explain you addition of matrix as well as subtraction of matrix, means sum of matrix, and I'll explain you difference of matrix. With this we'll complete this video. This is a question for sum of two matrix. We are having two matrix A and B. Let us first identify the order of this matrix. We are having two rows in this matrix, and as well as we are having two columns in this matrix. So order of this matrix is 2 by 2. Same order of this matrix is 2 by 2. For sum and difference of a matrix, you need to understand that order of both the matrix, means order of A and order of B must be equal. Then only we can do sum. If the order of this matrix is 2 by 2 and if order of this matrix is 4 by 4, we cannot add this both matrix. Okay, for addition you must check that the order of this matrix and order of this matrix must be same. Now let us solve this problem. We need to do A plus B. If this is A matrix and this is B matrix, find A plus B. He's saying us to find the value of A plus B. First, check the position of A matrix in place of A11. Here 1 is there, and in place of next B matrix, let me say this is B11. Here it is 6. You need to add this 1 and you need to add this 6 and write in the first position 1 plus 6. And here in this place A22, and in this B matrix B22, here it is 6 and here it is 4. We need to write 6 plus 4. Here A 3 3, here it is 3, A21, here it is 3 plus here it is 1. So we'll add that. Here we are having 2 and here 9. We'll write 2 plus 9. So if we add this matrix, we'll get our answer. 6 plus 1 is 7, 6 plus 4 is 10, 3 plus 1 is 4, 9 plus 2 is 11. This is my sum of matrix, means this is A plus B matrix. This is another example for a sum of matrix. If this is a matrix and this is B matrix, then find 2A plus 3B. For this also we'll be having same criteria. The number of rows and columns of this matrix and number of rows and columns of this matrix must be same, which means the order of A matrix and the order of B matrix must be same. Order of A is 2 by 2 as we are having 2 rows and 2 columns, and order of B matrix is also 2 by 2 as we are having 2 rows and 2 columns. In order to find 2A plus 3B, first we need to find 2A and we'll find 3B. We'll add 2A and we'll add 3B. This is A. If I multiply 2 with all the elements to this A matrix, which will be 2A. 2 ones are 2, 2, 2 6 are 12, 2 2s are 4, 2 9s are 18. So this is 2A. And let me find 3B also. We should multiply 3 to B, we'll get 3B. 3 ones are 3, 3 fours are 12, 3 threes are 9, 3 twos are 6. This is 3B. If I add this both matrix, I'll get 2A plus 3B. This is 2A, 2. Here it is 2 and here it is 3. 2 plus 3 is 5. Here it is 12 and here it is 12. 12 plus 12 is 24. Here it is 4 and here it is 9. 9 plus 4, 12. 9 plus 4, 13. Here it is 18 and here it is 16. 18 plus 16, 24. This is the answer of 2A plus 3B. Here in this way we can find the sum of matrix. Here he is saying us to multiply 2 with A and here he is saying us to multiply 3 with B. Now let us solve one example for difference of matrix. If this is A matrix and this is B matrix, he is saying us to find A minus B. For difference of matrix, the rule is same. We need to have the order of A and the order of B same. The order of A is 2 by 2 as we are having 2 rows and 2 columns. Order of B is also 2 by 2. The order of this and this is same, we can subtract this matrix. So we need to find A minus B. Same conditions will be applied for A minus B also. We'll subtract this 6 with this 5. We'll get 1. 1 minus 1, second element A 2 2 with this A B 2 2. Here we are having 1 and here we are having 1. 1 minus 1 is 0. Here we are having 3 and 4. 3 minus 4 is minus 1. Here it is 2 and here it is 8. 2 minus 8 is 4. Minus 4. 2 minus 8 minus 6. This is A minus B matrix. One more different example for a difference of matrix. This is a matrix A and this is a matrix B. Here we need to find 3A minus 2B. Criteria must be same. The order of A and the order of B must be same. So order of A is 2 by 2 and order of B is also 2 by 2. 2 rows and 2 columns. In order to find 3A minus 2B, first we need to find the value of 3A. We should multiply 3 with this A matrix. 3 ones are 3. 3 twos are 3 6 are 18, 3 threes are 9, 3 twos are 6. So this is 3A. And 2B, we need to multiply 2 with B. 2 ones are 2, 2 fours are 8, 2 threes are 6, 2 nines are 18. This is 2B. We are having the value of 3A, we are having the value of 2B. We need to subtract that. We need to make difference of this both values. So 3A minus 2b will be, we need to subtract this 3 with this 2. 3 minus 2 is 1. 18 minus 8 is 10. Minus 9 minus 6. See, this is minus 9 and we need to subtract minus 6. We'll get minus 15. Minus 9 minus 6 is minus 15. We need to subtract 6 minus 18. 6 minus 18 will get minus 12 here. So this is the difference of two matrix 3a minus 2b. This was another example for subtraction of matrix.